Hey guys, welcome back. We are now on question 8. So it says an advertising firm comparing two different 30-second videos for an ad for a new mobile phone. So this is actually quantitative data because they took numerical, how they liked the ad, and they came up with numbers between 1 and 10. So it looks like the first ad, they got numbers and an average of 6.1, and the second ad 4.8. But we understand how variability works. So maybe this is just based on variability. So what is there a difference between these two? Using technology, which of the following is a 95%? I changed this up depending on what version of the test. So if it said 98, 1 was an answer, but that doesn't matter now. Let's assume the 95% confidence level, and let's take a look at the question. Okay, so this is just purely a calculator question. I'm going to go to stats, and I'm going to do a 95% confidence interval, and I have 2 samples, and I don't have their standard deviation. So this would be a 2-sample t-test, and I have summary statistics. So I have all this data. That's exactly what's on my piece of paper here. So what should you write on your piece of paper to help support your learning? Question number 8. That's right. A 2. We're just going to copy the calculator. We're going to do a 2-sample t interval because we have an x bar 1, an s sub x1, and an n1, along with an x2, s sub x2, and n2. What else am I going to need? I'm going to need no pooling, don't click pool, and I'm going to keep it 95. So let's type these values in. All right, and so what do I got here? I have a slightly different order, don't I, right? So you do have to know what each one of these are and pay attention. So when you transfer this information, that's very important when you're transferring it into the calculator. Some people may have missed it because they transferred the wrong information. All right. What else? The confidence interval was 95, so we type it in like that. And what came out of the calculator? Well, I could be looking, depending on the question, for something else, but they listed it as an interval. So I'm looking for this C lower, C upper. C lower, C upper is this. Right? And then when I compare, I see that that's definitely question B. They've rounded it. They rounded this to 0.42 and that to 2.18. All right. Now, what you might be thinking, well, what is this? This doesn't make sense. This is the difference. So you've actually used this data to figure out if you think there is a difference between the two. And it's because 0 isn't in the interval, you do have sufficient data to support that there is a difference between ad 1 and ad 2. All right, question number 9. An ad firm is comparing 2 different 30-second videos. And so it sounds like the same type of question. Oh, it is exactly the same. What does it mean when we create the interval? All right, so that goes to, what does that mean? If you did a 98%, so in here, originally the problem said 98%, what does that mean? We're 98% confident that this interval we just created, now this one was 95%, but we're 98% confident that the interval we just created captures the true difference. We don't know what the difference is, but we're 98% confident that this captures the true difference. And that's exactly what that means when we do that. So question number 9 goes back to our notes from question number 1, 2, and 3. All of these questions, and even question number 4, all of it is built into understanding what it means when you do a confidence interval. So what should we write? We are, in this instance, I'm going to change it because I did do 95% confident that the interval from 0.42 to 2.18 captures the true difference, and it's the mean difference between the two adds. Right? And so we don't know what the truth is. We know that variation, we know if we took another sample set, we would get slightly different numbers here. But what we know is that we wouldn't get wildly different numbers. And so we're confident it's somewhere between that number, okay? All right, last multiple choice question, then we'll get to the free response. Once again, there was a kind of a catch to this question. It says, a psychologist, Dr. Weisgrip, claims he has a secret sleep tape that will make kids get better at algebra. All you have to do is listen to it while you're sleeping. So we have to figure out if how you did on the test before and after. So notice that there's not 10 students, there's only 5 students. So this one is the third type. So question number 10, I know a lot of kids miss this idea that this is the third kind of a difference of mean question. So this is like the example in class where you use the memory strategy. Okay? You were your own matched pair. So what does that mean? This is not 10 people, 5 people from sample group 1 and 5 from sample group 2. This is just you. So we really only have, this goes back to, this is just like putting in data, just like you would normally. So your raw data here is really just the difference between the pre and the post test. And it's set actually to take post test minus pre-test. So if the post test was 70 minus the pre-test, I actually get +2, right? Pre minus post, I get -1. Post minus pre, I get +1, right? +1. 68 minus 65, +3. Okay. Now you want to do a 99% confidence interval. So I'm going to show you how to do that. All right. So I go to my on-screen and I got some data, these 5 students. And this has to do with some Dr. Weisgrip, so I'm going to call that Weiss. All right, so the first number I got was a +2, -1, +1, +1, +3. Okay, so that's my data. And now I'm going to do a 99% confidence interval with this data. So I go to menu, stat, confidence, and this is a Z interval. These are numbers, so it's not a proportion, and I don't have 2 samples, and I don't have the standard deviation, so I can't do a Z interval. I got to do a T interval. And this time I have data, so I'm going to leave that word data. I've called the list Weiss. All right. Now they've asked me to do a 99% confidence interval, so I'm going to change this number to 99. All right. Hit OK. There it is. It says my X bar is 1.2. And my margin of error is 3.05. Says my degree of freedom is 4. So you're like, how do I get that number? So back to your table here. Right? If the degree of freedom, if 5 was my number and degree of freedom is 4, and I want to do a 99% confidence interval, I scoot over here, and that's where I get this number, 4.604. Aha! 4.604. Now this is your standard deviation, S of x, that's the number right there, 1.48, and divide by the square root of n. Right? All right, so what's another way to double check this? Let's write this down. So I put in my data. I named it, which could be anything, but I named it Vice. And then inside my spreadsheet, I went to Stats, Confidence Interval, and I picked a T interval. Right? And then I left it on the data setting because I did put in the 5 data points, okay? Now, what did I get out? I got an X bar, a margin of error, degree of freedom, an S sub x, and an N of 5. So what does that mean? Well, using our formulas, we know that it creates a confidence interval like this, right? And so how does it do that? It does it with its t star value and the S sub x over the square root of n. So it creates it by taking that, and where did I get my t star value? I got that from table B, right? Following my chart. So my degree of freedom was 4, right? And then I needed to be 99% confident, so I followed that number over and that number up, and that's where I got that number 4.604. So that's what went here. Then the S sub x, 1.48, all over the square root of n, which was 5. Could I double check this? Absolutely. So all these numbers, the calculator multiplied and should equal the margin of error. So let's see if that worked. If I turn my calculator back to the normal setting, right, 4.604 times 1.48 divided by parentheses the square root of 5, I get the margin of error, 3.05. 3.05. Check out the next videos for the free response.